we're looking at multiplying radicals, the way that you multiply radicals, first of all, for what we're doing today, they have to have the same index. So that means that they have to both be square roots, they both have to be cube roots, fourth roots, fifth roots, so on and so forth. Okay? So what happens is that you multiply the radicands together. The radicands are the part that's underneath. And then if they have numbers in front of the radical, you also need to multiply the numbers in front of the radical. Okay? So if we had a root b times c root d, what that turns into is a times c root b times d. Okay? So you take the front numbers and you multiply those two together, and then you take the numbers underneath, which are the radicands, and you multiply those two things together. Okay? You still have the option to use your box method that we've used before with polynomials, or you can use just distributing. Okay? So what you want to remember is the coefficients get multiplied and the radicands underneath get multiplied. So outside by outside, inside by inside. Okay? So if we looked at this first example, we're going to do the coefficients, so the 2 times the 3, or the outside by the outside, and then the radicands, or underneath, which is the 6 times the 7. So we're going to do 2 times 3 square root of 6 times 7. Okay? So again, we've got these two on the outside and these two underneath. Okay? Now, underneath, I could multiply the 6 times the 7 and get 42, but then since it's under a root, I'm just going to have to break it down to find values that multiply to 42 to see if I have any pairs. So instead of multiplying these, I'm just going to break down any of the numbers that I have. So this is 2 and 3, and then the 7 is prime. Okay, notice I have no pairs, so I can't actually pull anything out. So then that means that I just simplify by multiplying underneath and then multiplying what was out in front. So the 2 times 3 is the 6, and then the 6 times the 7, or the 2 times the 3, which gets us to 6 times the 7, is root 42. So this is our final answer. Now, this was a monomial, or one term by a monomial, which is one term. Here we've got one term by two terms, so a monomial by a binomial. So we could set this up in boxes. Right? So I could have one row by two columns, or you could set it up so that you've got two rows in one column. Either is fine, but since you have one, you need one row or one column, and since you have two, you need two columns or two rows. Okay? So, and make sure that they match accordingly. So the one term goes with the one row in this case, or the one column in this case, and then the binomial goes with the two columns, oops, that's a 12, or the two rows on this one. Okay? Again, you're still going to do the same thing where you multiply what's outside. Now, in this case, we have unsaid ones here, right? So now in front, we have the 1 times the 1, which is just the 1. Underneath, we have the 6 times the 3. And again, I'm just going to write it as 6 times 3. In my second box that we have, this also has an unsaid 1 out in front, so we're going to do 1 times the 1, which is 1. This 1 times this 1 is the 1. And then we're going to have underneath the root, we have the 6 times the 12, so we can just write that. Now, you could multiply the 6 times the 12, but I'm just going to have to break it down when I'm simplifying my radicals. So when I simplify my radicals here, I'm going to do, this is 2 times 3. This is 2 times 3, and this is 3 times 4. So in this radical, I have a pair of 3's. Now, it doesn't matter that one of the 3's came from the 3 and one of the 3's came from the 6, because they're both underneath the radical. So I can still pair them up together. So these come out of the radical. So then we get 3 root 2. The 3 was really timesing by the 1, and then the 2 is underneath. On the second one, we have a group of 3's. Oh, and let's talk about how I didn't finish breaking down 4. So 4 is 2 and 2. And I have a group of 2's. And then I've got this loner 2 here. So when I bring it out, I've got the 3 that I can bring out, the 2 that I can bring out, and then a loner 2. So 3 came out, the 2 came out, and then our loner 2 that was left over from right here. So then I can multiply those. So then that gives me 3 root 2 plus 6 root 2. But now look, these are now like terms, right? So once we finish multiplying and simplifying our radicals, you need to check and see, are they like terms? So we've got the 3 and the 6 are like terms. Sorry, they're both square roots and 2's underneath, so they're like terms. So we're going to add the 3 and the 6. So then that gives us 9 root 2's. Okay. Now we would have got the same thing if we had done this part over here. We also could have just done with our distributing the root 6 times the root 3 and the root 6 times the root 12. So there's plenty of ways that you can go about doing that. So we'll look at the distributing on the next one. So here when we're distributing, now notice on this one, the 4 doesn't have a root, right? It's technically an unsaid root 1 because the square root of 1 is 1. So if you're thinking of multiplying the outside by the outside, this doesn't have a root, so the 4 is on the outside. So we're going to multiply the 3 times the 4, right? Which gives us 12. And then underneath, we're going to multiply the 3 times the 1, which is just 3. Or you can write the 1 so that you can see how we multiplied that. Okay. If we multiply the second term, we're going to do 3 root 3 times 3 root 5. So again, we have the 3 and the negative 3. So notice you take the sign with it. So the 3 times the negative 3. There's a plus in between. And then the square root of, and then you take the radicand. So the 3 and the 5. So 3 times 5. So then we can simplify. Notice here, there's nothing to pull out because 3 is prime and 1 is prime, so then it's just 12 root 3. Here, we need to multiply these two together. If I check under my radical, there's nothing to simplify because both 3 and 5 are prime. So then we do 3 times negative 3 is negative 9 root 15. I check to look at my radicals. The radicand is 3 and then 15, so I cannot add them together, so then this is my final answer. Now we can also do it with any other kinds of roots, right? So we could do cube roots as well. So it's the same process, it's just when you're breaking down the root, you have to remember with cube roots that it's groups of 3 that you need. So we can set it up with our boxes if you want. So you've got the cube root of 4, cube root of 2, minus the cube root of 5. Okay. So again, you're still multiplying outside by outside. So here we have unsaid 1's that you'd be multiplying by. So we've got 1 times 1 is the 1. And then underneath the cube root, make sure that you take the index with you, that you don't accidentally drop that. That's something that I sometimes even do. So we do 4 times 2 underneath, because we're multiplying the radicands. Okay. So then our second term, we're going to do the coefficients again. So this one has a coefficient of 1 and negative 1. So we do 1 times negative 1 is negative 1. And then underneath, again, keep the cube root. We've got the 4 times the 5. Okay. So notice I didn't actually write 20 or I didn't write 8. That's because in a minute I'm going to have to break those down. So I'm just going to leave it so that I can break it down. So the 4 breaks down to 2 and 2. The 4 breaks down to 2 and 2. The 5 is prime. Or the 2 is prime. This 2 is prime. So we need groups of 3. So notice here I've got a group of 3 2's. So these 3 2's are going to come out in front. So 2, and then there's nothing left under the cube root, so I just leave it as is. I do not have a group of 3 in this radical. I have 2 2's, but not 3 of them, so I can't do anything. So I just leave this as minus the cube root of, and then I'm going to multiply all those numbers together. So 2 times 2 is the 4 times the 5, which gives us 20. So I have 2 minus cube root of 20, and that gives me my final answer. Now, this is 2 terms by 2 terms, or what we call a binomial times a binomial. Okay. So again, you can do where you do foiling, where you do the firsts, the outsides, the insides, the last, or you can set up a box, or you can just do multiply, 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 multiply. Whatever way you want to look at it. All of them get you to the same spot. So if we have root 2 minus 5, 7 root 2 minus 5. Okay, so if we've got our boxes, we're doing the outsides by the outsides, insides by insides. This has an unsaid 1, so we do 7 times 1 gives us 7. And then the insides, we're doing root 2 times root 2, so we're just going to have root 2 times 2. Okay. In the next box, we've got 7 times the negative 5, so there's no root on this one, so the negative 5 is the outside, so we do 7 times negative 5 is negative 35. This one has a root. This one is, remember, an unsaid root 1, or I don't have any root to multiply on this one, so I just keep it as the root 2. I look at this box here. This one doesn't have a root. This has an unsaid coefficient of 1, so the negative 5 is the coefficient, so negative 5 times by the 1 is negative 5. And then this one has a root and this one doesn't, so I can do either think of this as the square root of 1 times the square root of 2, which gives us the square root of 2, or this one doesn't have a root, so I just times by the root 2. Either way is fine. My fourth one, just kidding. We've got negative 5 and negative 5. Those are just numbers, so negative 5 times negative 5 is positive 25. Okay. Now, notice here that we have a pair of 2's. So this pair of 2's can really come out of the radical. So I really have 7 times 2, and then minus 35 root 2 from this box, minus 5 root 2 from this box, and then plus 25, right? So I'm just going to put 14 above my 7 times 2 because I can simplify that here. But notice we have like terms. Notice these are both square roots of 2's, so that means that I can add those. So if I have negative 35 square root of 2 and negative 5 root 2, that gives us negative 40 root 2. I also have like terms with our numbers, right? We have 14 plus 25. So if we're doing the 14 plus the 25, that gives us 39, and then minus our 40 root 2. Now it's conventional to write your number and then whatever your number is with your root. Okay? It's conventional to write it that way. So you could also write this answer as negative 40, well, no, it's not original, negative 40 root 2 plus 39. This is also an acceptable answer. This one is conventional. Okay? So just be aware of that. Okay? Let's have you try this example on your own. So pause the video, try it, and then let's see what you get. Okay, so hopefully you paused it. So I'm going to show you foiling. So we're going to do 5 times the 5, which gives us 25. And then we've got root 2 times root 2, so 2 times 2 underneath. So then we're going to do 5 root 2 times negative 3, so the 5 times the negative 3 is negative 15, and then we keep the root with it. We do 3 times the 5, because those are the coefficients, so 15, and then I keep the root 2. And then we do the 3 times the negative 3, which is negative 9. Okay. So the 2's are a pair that come out, so we do 25 times 2, which gives us 50. These are like terms, and in this case, they go to 0, so this will be plus 0 root 2, and then minus 9. Well, I don't actually have to write this, right, because that's just 0. So notice we also have like terms with the 50 and the 9. So if I do 50 minus 9, it gives us 41. So our final answer is 41.